What's going on, everyone? Hopefully you enjoyed the last video. And in today's lesson, we're going to go over just a couple of sample problems and what they might look like with all these kind of different equation representations and which one that we're going to use for these examples specifically. All right, let's go ahead and let's dive right in. So if we're looking at this problem, we're looking at points A and B on a straight line, and we're basically separating two plots of land here. So what we want to do is write the equation of this line, pass into the points A and B, and we know that some tree is going to be located at 2530, point C. So let's determine whether that tree, point C, 2530, is on the boundary line. So we covered this in a past video of how to figure out if a point is indeed on a line. You just plug in the x and y coordinates, assuming that you already know what slope and y-intercept are, and see if that equation holds true. See if both numbers at the end do in fact equal each other. And now this is just a little bit of context, but it's the same exact method of solving. So if I'm looking at a graph, in our last video we covered point slope form or point gradient form, which is a really convenient way to write it depending on what the problem's asking for. But in this case, I'm looking at this and I see a graph, so I am going to go ahead and use that slope-intercept form, y equals mx plus b or y equals mx plus c. It doesn't really matter what you call that. So we know that m is going to be our slope or our gradient. We know that c is going to be the y-intercept. So let's go ahead and take a look at what we have here. I have 2 points, A and B. I know that A is going to be at the point 6, 8, and I know that point B is going to be at the point 12, 10. That's important to know because now I can really get my slope. Because if just by looking at a graph, sometimes you can't get the slope from it, but you want to be as specific as possible. So since I'm given A and B, I really want to make sure that I use those coordinates because those are definitely going to be the easiest ones to pick out, and I know that they are going to match up on this graph nicely. So I know that if I have 2 different points, that I can go ahead and I can find this value of m right here for the slope. So I know that m, my slope or my gradient, is going to be y2 minus y1 all over x2 minus x1. So that's going to give me what? I'll use 10 minus 8 all over 12 minus 6. And again, notice that 1210 is going to be right here and 6, 8 is going to be right here. They have to match. So if I go ahead and simplify this down, that'll give me 2 over 6, and that'll go ahead and give me 1 over 3. So my slope is 1/3. So just to keep this clean, I'm going to go ahead and erase this. Okay. So my slope is 1/3. And now all I need to figure out is what is my y-intercept. Okay, so just by looking at the graph, I can see that it is going to cross right here. And I can actually go ahead and verify that, because what if it was like 6.001 or 5.999? It wasn't exact. So if you want to ever verify that, notice that I can just plug in m right here. And now I have 3 variables, one being my y-intercept and another being an x and y coordinate. So what I can do is I can plug either one of these into this equation for my x and y values and figure out what that missing variable, c, is. So let's go ahead and let's use, I don't know, 6 and 8. It doesn't matter because it's all on the same line. It'll give out the same value. I'll have 8. My y coordinate is equal to 1/3 times 6. My x coordinate plus c. So then 1/3 times 6 is just 2. So c would be equal to 6. So indeed, this would be 0, 6. So my b value is going to be b or c, depending on how you're defining it. It's going to be 6. So my equation is just y equals 1/3 x plus 6. There we go. So just from 2 points on a graph, I have my linear equation written in point slope or point gradient form. And now I want to figure out what the question's asking, which is, hey, is this tree right here 2530? Or located at 2530, I should say. Is that indeed on the line, on the boundary? So, in just like the other examples that we did in previous videos, I'm going to take this x and y coordinate and just pop it into here. And if both numbers end up equaling each other on both sides of this equal sign, then I know it's going to be there. And if it's not, well, then it's not. So if I want to plug in a y, I would plug in my 30 times 1/3 of 25 plus 6. And I can already tell personally this is not going to work. And that's because I know that 25 divided by 3 is not going to give me a whole number. So that means no matter what I do here, I'm going to have a number over here that's going to be a decimal or a fraction, and that's not going to equal 30. But if you wanted to go ahead and solve it, if you wanted to eventually simplify it down, you would end up with 43 over 3. And once you get 25 over 3, add that 6 to it. And again, you can already tell that's not going to equal each other. So what does that mean? It means that the tree does not lie on the boundary line. Okay, so again, we've covered this exact question type, or I'm sorry, this exact solution method in previous videos, but just with no context. All that's different here is just a little bit of context. So in this case, I know the tree's not on the boundary line, and I went ahead and showed my work. Perfect answer. Let's take a look at one more example problem. Let's say a sailing boat is going to be moving along a straight line with this equation, negative 2.5x plus y equals 3. So it's given to us in a more standard notation. It's not given us in point slope or point intercept form. I'm sorry, slope intercept form. Now, let's determine whether some kind of tanker is going to be located at 3, negative 2, and see if that is going to be on the trajectory of the sailboat to see if like maybe a possible collision is needs to be avoided. So I'm going to take negative 2.5x plus y equals 3, and I'm going to turn it into a form that I like to use and one that's more simple for me. I'm really used to this y equals mx plus b form, which is that slope-intercept form. So let's go ahead. If I have negative 2.5x plus y equals 3, I just bump that over. I would have 2.5x plus 3. Okay, so now that I have this in a nice easy form, again, just like our last problem, I'm going to see if this is indeed on this line. So if I plug 3 in for my x coordinate, plug negative 2 in for my y, if both sides are equal, well then it's on the line, and if not, it's not. So if I put in negative 2 is equal to 2.5 times 3 plus 3, kind of similar to the last one, I can already tell this is going to be a decimal, or have part of a decimal here. In that case, I'll have 7.5 plus 3. I'll have negative 2 is equal to 10.5. These are super not equal to each other. So in this case, no, the tanker is not on the trajectory of the sailboat. There's no possible collision or anything like that. We're good. So what B is asking me for is to find the exact y coordinate of the port of arrival for the sailboat if the x coordinate of that port is 10. So very similar. Now I'm just asking, hey, what's that y coordinate instead of are the two sides going to be equal to each other? So again, I have y is equal to 2.5x plus 3. And I know that the x coordinate is going to be 10. So y would be equal to 2.5 times 10 plus 3. Y would be equal to 25 plus 3. So y would be equal to 28. So that y coordinate is going to be 28. And to be specific, that port of arrival is going to be at the coordinates 10, 28 in this problem right here. Okay, so all I did here was move a couple things around and plug a couple points in. So it's always depending on the context of the question that's being asked, but typically these sorts of questions will have a solution method that you are accustomed to solving. All right, so I hope these two example problems kind of shed a little bit of light into how to rearrange these equations to make them a little bit easier to use, and what the most common types of solutions methods you'll be asked to do. All right, so hopefully you enjoyed that one, and I'll see you guys in the next video.